Okay, so for our purposes, a linear transformation will take vectors v in some vector space, capital V, and map them to vectors w in some vector space, capital W. Okay? And again, I already said it, but these don't even have to be vectors. These don't even have to be vector spaces. But actually they kind of do, because otherwise the rules don't make sense. Okay? We'll call it a rule T. Okay? And it gives us, it's kind of like a distributive law. It's not a distributive law, it's a law of linearity. It's a property of linearity. Okay? It's just kind of what you hope for. Okay? And if C is a number, T of V equals C, T of C times V equals C times T of V, and I don't even need the subscript on this one. There's only one vector, so it's kind of redundant, so we'll just eliminate it. Okay? And that's kind of it. Okay, now there are other properties. T of 0 has to equal 0. Okay? But that follows from these two properties anyway. Okay? If C is 0, you're going to get 0 here and here, right? And if it's a vector space, well, you remove all ambiguity. And we're not going to worry about that right now. We'll get into some more detailed proofs after we learn to do some fairly straightforward proofs, right? Which will be appearing on the test. Okay. Now, if T of V is defined to be A times V, where A is a matrix, then T is a linear transformation. And that's easily proved. Okay? T of V1 plus V2 would be equal to what? Well, since T of V is A times V, T of V1 plus V2 is A times V1 plus V2. Everybody understand that step? Here's a definition of the transformation. Now we're applying it to V1 plus V2, right? So it's going to be equal to what we get when we multiply the matrix A by V1 plus V2. And what's that equal? It's equal to this, since A is a matrix. We know a matrix does that, right? We've proven that. And this equals then T of V1 plus T of V2. Since that's how we define T, right? So if T is defined by a matrix A, It's a linear transformation. Now, I just proved this property, but I kind of leave it to you to prove this property. It's very simple. You just write it out in a very similar or analogous manner. Okay? And it just comes down to A times CV is C times AV, which is true for matrices. Okay?